question 17.9, it is a tricky question. What we're given 0.37 grams of calcium hydroxide added to a 500 milliliter solution of water. And it's allowed to come to equilibrium. Are we saturated or not? So basically what we want to do is we're looking at the equilibrium for calcium hydroxide. So that can break down into calcium 2 plus and 2 hydroxides. We want to basically see what's the concentration, right, if our KSP for this reaction is calcium times hydroxide squared. We want to basically see, does this mass of calcium hydroxide, what concentration does it give us? And then given that concentration, what is that in relationship to our KSP? So the first thing we need is basically the molecular weight of calcium hydroxide is 74 grams per mole. And we know moles equal grams over molecular weight, so we have 0.37 grams over 74 grams per mole, and we're looking at approximately 0.005 moles of calcium hydroxide. But we need to find what's the concentration of calcium and what's the concentration of hydroxide. And for that, we need to think about the stoichiometry, right? How does it break down? So for every 1 mole of calcium hydroxide that breaks down, we get 1 mole of calcium and 2 moles of hydroxide. So if we have 5 moles of calcium hydroxide, we would make 0.005 moles of calcium. And then we want to think about the stoichiometry. We're going to form twice as much hydroxide. So we would have 0.005 moles times 2. We're going to have 0.01 moles of hydroxide. So now we found moles of hydroxide, moles of calcium. Remember, for our KSP or for our Q, we need to know our molarity. And so to find molarity, we simply divide moles per liter. And in this reaction, we have 500 milliliters, which is 0.5 liters. So we're going to divide both these molar amounts by 0.5 liters to find that we have a concentration of 0.01 molar calcium, and that's a 2 plus, and we have 0.02 molar hydroxide. So now we want to calculate Q and compare that to our KSP, and remember Q is the exact same concentration. We just use that to compare, are we at equilibrium, are we beyond equilibrium, to see if we're a saturated solution or not. So Q equals, we're going to put in our concentration of calcium, 0.01, times our concentration of hydroxide, 0.02 squared, and we multiply that together. Q equals 4 times 10 to the minus 6. And so we want to compare that to our KSP, and we'll see that Q is less than KSP, right? 4 times 10 to the minus 6 is a smaller number than 6.5 times 10 to the minus 6. So because Q is smaller than KSP, how would we get a smaller value? Well, these concentrations must be less than what they are at our KSP, at our solubility constant. So as a result, this is not a saturated solution. Right, our calculated value of Q is less than our KSP, and that's because we have a concentration of calcium that's less than it can hold at equilibrium and at its saturation maximum, and a concentration of hydroxide that's less than it can hold at its saturation maximum. So more can go into solution. So that's pretty easy. The second part is a little bit harder. Basically, if you mix it with any of these 3 beakers, or any of these 4 beakers, will a precipitate form? And so to think about that, we need to look at what's our equilibrium. Our equilibrium is calcium hydroxide breaking down into calcium and 2 hydroxides. So we want to look at something that has a common ion with calcium hydroxide. And so immediately, HCl, NaCl, we can cancel those out because we don't have any common ions. So now we're going to look at calcium chloride, and let's focus on the more concentrated one, because if we're going to get a precipitate to form, it's going to be in the case where we have the most concentrated one. And just to confirm, right, calcium chloride is going to break down into calcium 2+ and a 2 chloride. So here we have a common ion, and it's calcium. So to figure out if a precipitate will form, if we add 50 milliliters of our solution from the previous question to 50 milliliters of this solution, we need to find our new molarity. And to do that, we need M1 V1 equals M2 V2. Our molarity from our first set of conditions and the volume from that set of conditions equals the molarity at our second set of conditions at that volume. So in the previous case, we had a 0.01 molar solution of calcium hydroxide, and we want to figure out what's our concentration in our new solution. So if we mix 50 milliliters of our first solution with 50 milliliters of our second solution, our new volume is 100 milliliters. So this calcium hydroxide sample, we've got 0.01 molar calcium, we've got 50 milliliters, and we don't know the concentration at our new volume, and we have 100 milliliters of that. So our concentration of calcium, our concentration is going to equal 0.005 molar calcium. And from this 0.01 molar solution of calcium hydroxide, we're going to get twice as much hydroxide because we formed 2 of those, so 0.02 molar, and we're going to take 50 milliliters of that and mix it with another 50 milliliters of this other solution to get 100 milliliters total. And what's the concentration of hydroxide in that solution? It's going to be twice as much, 0.01 molar hydroxide. So that's from the previous question. Now we're going to mix it with this solution, solution 3 we're going to mix it with. So solution 3, it is 1 molar in calcium, and we're going to take 50 milliliters of that, and we want to find what's that concentration after we mix it with another 50 milliliters from part A. So 100 milliliters total, and that concentration is 0.5 molar calcium. So right, these two are from part A, these concentrations, and this is from beaker 1, 2, 3. So now we want to basically recalculate our value of Q, and Q still equals calcium 2+ times hydroxide squared. And now what's our value? What's our concentration of calcium? 0.5 molar from this beaker, 0.005 molar from here, so it would be 0.505 molar calcium. Our concentration of hydroxide is 0.01. So now, and that's squared, so Q would equal 0.01 squared times 0.505, and we find a Q equals 5.05 times 10 to the minus 5. And remember, KSP was something on the order of 6.5 times 10 to the minus 6. So now we've calculated a Q that is greater than our KSP. So how do we do that? We do that because we have a higher concentration of calcium and a higher concentration of hydroxide than the solubility constant. So as a result, right now, we will see a precipitate. A precip will form from beaker, and there's no R right there, beaker 3. All right, let me know if you have any other questions about the homework.